Hello, welcome back to my recorded classes. This recorded class we are discussing the topic from discrete structure from module 2 2.5 section sample problems, especially merge sort we are discussing here. So let's start the topic here. Section number 2.5 sample problems. Only here merge sort. How merge sort is working we can discuss here with one example. So we have a list of unsorted object, a sequence we have S of n unordered object. Actually we want to sort this one, this sort with this list using divide and conquer design pattern. Divide and conquer design pattern means by using merge sort. So what we are doing is first divide our elements and n unordered objects into two lists. Okay, for example, here you can see what we are doing. See here one example: 38, 27, 43, 3, 9, 82 and 10. Correct? We have 7 elements here, 7 numbers are there in the unordered pair here. It is not sorted, unsorted list of 7 elements. So what we need to do is divide this list into 2. Okay, that means we have 7 elements. Okay, 7 elements means 7 divided by 2. 7 divided by 2 means 3.5. Okay, we can take the ceil of this function, ceiling of 3.5 means 4 elements. So one list we have 4 elements, and another list we have 3 elements will be there, second list, correct? 3 elements will be there in the second list because totally 7 elements. So divide the main list into 2 accordingly. Here 2 list here, see you can see one list here 4 elements, 38, 27, 43 and 3. First 4 and next 3, remaining next 3, 9, 82 and 10. So this is the first step we need to do, divide. Split the input into 2 sub list, calling it as S1 and S2 with ceiling of n by 2. Total number of element, how many numbers are there, divided by 2, ceiling of that one. Ceiling means the next number. For example, if you are getting, when we are dividing 3.5, ceiling of this, ceiling we are representing like this, the top bracket like this. Ceiling of 3.5 means the next number we will take, and automatically the next list will be floor of n by 2. Floor of n by 2 means the below number. So we can get it, next list we have 3 elements, like so 4 plus 3, totally we have 7 elements in that list. Okay, this is the first step, divide. Now after that conquer means the sub problem again solving them by recursively. That means whatever we are getting the sub list, again divide into half and half, just to continue this process recursively. Okay, this is what we are calling divide and conquer design pattern. Okay, you can see here what we did this example. So next what we are doing is this list having 4 elements, divide by 2. So 4 divided by 2, we have 2 elements in the one list, another list having 2 elements. Okay, so divide again half in that list, and here also divide again half. Here 3 elements are there. So 3 elements, when we are dividing, one list will be 2 element and another list will be 1 element, correct? So totally 3 elements we have. So this is we are telling conquer. So we have a problem here. We are dividing into sub problems. We divide the list into 2. Okay. After that again we are continuing recursively this process. Again sub problem. Okay, sub problem until we are getting 1 element in the list. See these 2 again we are dividing into 1 elements in each, 38 and 27. This also divided by 2 list 43 and 3, 9 and 82 again divide by 2 like this, and lastly we have 1 element, we are keeping that one. So first when we are getting an unordered list of elements, we are dividing just half, we are making 2 unordered list, then again splitting into 2 until we are getting 1 elements. Okay, like this, 38, 27, 43, 3, 9, 82 and 10. Now next process what we are doing is we need to combine this one. We need to combine, that is the next process, and after that we are going to the solution. That means it's sorted list. Now you can see combine. Combine means the solution sub-problem into the solution of the original problem. Merge the sorted halves together. That is the combine problem. So you can see, for example, here. Now 38 and 27 we are merging and sorting. We will write together one list. That means the 38 and 27, just compare these two elements. 38 and 27. Which is the smallest element? 27 is less than 38. Correct? 27 is the smallest one, because we are sorting in the increasing order. Small one first we are writing. So 27, then 38. So combine process, when we are doing sort and combine. Okay. Sort means compare these two elements, 38 and 27. So 27 is the smallest element, that we are writing first, then 38. Now another two elements again we are combining here. Okay, 43 and 3. So that 3 and 43, when we are comparing, 3 less than 43. 3 is the smallest one, 43 is the bigger number. So 3 we are writing first, 43 we are next we are writing. Then again 9 and 82 we are comparing. 9 is smaller, sorting that one and combine 9 and 82. Same, last number 10 we are writing same. After that again this process continuing. Okay, just merging these two lists and sort. Merge and sort these two lists again. Now when we are merging these two lists, you can see first what we are doing here, 27. This is the first element here, and 3 is the first element here in these two lists. Just compare these two elements, 27 and 3. So we can see 3 less than 27. Correct? 3 less than 27. So 3 is the smallest one. So that first we are writing. So this 3 is done now. Okay, now after that 27 and next element here compare, 27 and 43. So 27 is the smallest number, 27 less than 43. So sorted array 27 will come the next number. So 27 we done. After that we compare with the second element here, 38 with 43. So we can write 38 is less than 43. So 38 is the smallest next element. We will write here. Then lastly 43, that number. So we will get a sorted list, sorted array, sorted list from these two combined list. Correct? So this is 3, 37, 28 and 43. The same process will repeat in another pair also here. See 9, 82 and 10, next one. See here 9, 82 and 10. So what we are doing, just comparing 9 and 10 here. So 9 less than 10, 9 is the smallest number. So its sorted number will come first, smallest one. So 9 we done. After that 82 and 10 we will compare. So 10 less than 82, correct? So 10 it will come second, then 82. So we will get a sorted list here. So what happened here? We are getting two sorted arrays here. This is one sorted array. This is the next sorted array, correct? Now again combine these two sorted arrays. Compare and combine again. First what we do, this 3 compare with this 9. So we can see 3 less than 9. So 3 is the smaller one. We will write here first 3. Now this 3 done means take the next number 27 here. 27 and 9 we are comparing. So we can write 9 less than 27, correct? So 9 will come to the next number. So 9 also we done. Next we go 27 and 10. 27 and 10. So we can write 10 less than 27. 10 is the next smallest number. So 10 will come here. Then 10 done. After that 27 and 82. So 27 is the smallest number. 27 less than 82. So 27 will come to the next list. Then after that continue this process. 38 and 82 comparing. So 38 is the smallest number, 38 less than 82, the comparison. So 38 will come to the list. Then again 43 and 82 will compare. So 43 less than 82. So 43 will come to the list, and last number is 82. So we will get a sorted list by using merge sort. Okay, that means the unordered list of n elements we are sorted, and we are getting a sorted list, correct? Sorted list of n elements. So this is what the merge sort algorithm working. So we have a problem, we divide into sub problems. After that this process is continuing. After that combine the list and sort the elements, so that we will get a sorted list. So this is what the merge sort algorithm working. I hope you understood this one, what we are doing. in the merge sort algorithm. So these are the steps as I told you here: divide, conquer and combine. Okay, divide the list into two first. After that, conquer, that means solving them recursively, sort the list half until we get to one element. Then combine, merge the list and sort. Merge and sort we are doing together up to the end until we are getting in one list. So let me see the process here. So the merge sort algorithm based on sorting recursively by splitting the group into two. Okay, splitting the group into two groups and proceed with sorting until the one element is left in the final group. Correct? That is what we did in that example. Now another important point we need to discuss here is two sorted list. Okay, two sorted list. You can see in this example, the last example whatever we discussed, see here we have two sorted list: 3, 27, 38, 43, 9, 10 and 82. So two sorted list. First sorted list, how many elements are there? 1, 2, 3, 4 elements. Next sorted list, how many elements are there? 1, 2, 3 elements are there. Correct? So we have two sorted list. Lastly we are getting. Now what this is telling, two sorted list with m elements and n elements. First list having m elements and second list having n elements can be merged into a sorted list using no more than m plus n minus 1 comparisons. How many comparison maximum possible? M plus n minus 1 comparison. That means this example just before we discussed it, we are getting a sorted list here 4 elements, correct, in the first sorted list, and second sorted list we are getting 3 elements. Okay, keep in your mind sorted list. Okay, once again I will show that one. See here, this one, the first sorted list here, how many elements are there? 4 elements. Second sorted list here, how many elements are there? 3 elements are there. Then combine and we are sorted the full list, correct? We are making a sorted list, full list. Okay, now for combining and sorting these two lists into one, how many comparisons needed? That is why that rule is telling how many comparisons maximum needed. What we did here, first we compared with 3 and 9, which is the lower one, we are writing here. Like that, how many comparisons are needed? We are telling here. How many comparisons are needed? Maximum m plus n minus 1 comparisons are needed. That means here, first list we have 4 elements, correct? Plus second list we have 3 elements. So how many comparisons totally needed to merge these two lists together as a sorted list? 4 plus 3 minus 1 comparison. That means 4 plus 3 7, 7 minus 1, 6 comparisons maximum needed in that example. So that's what this rule is telling. Two sorted list having m elements and n elements can be merged into a sorted list using no more than m plus n minus 1 comparisons. I hope you understood this meaning. Okay, now let me do some examples. Exercise 2.5, you can see, use a merge sort to sort the list 4, 3, 2, 5, 1, 8, 7, 6 into increasing order. Show all the steps by using algorithm. Okay, so here we can see. So what we did actually, first check how many elements are there in the list total, and so unordered list, how many elements are there? You can see 1, 2, 3, 4, 5, 6, 7, 8 elements are there totally, correct? 8 elements are there totally. So 8 elements means 8 divided by 2. That means we divide into two lists having 4 elements each, correct? So that's what the first step we are doing. You can see in the answer on this side. So 4, 3, 2, 5, 1, 8, 7, 5. We are splitting, dividing into two group. First 4 elements in the first list, 4, 3, 2, 5, and next 4 elements will be in the next list, 1, 8, 7, 6. Now 4, 3, 2, 5, again 4 elements are there here. Divide into two group, like, okay, 4 means 4 divided by 2, that is two numbers. 4, 3, first two numbers and next two number, 4, 3 and 2, 5. Here also the same, we have 4 elements here, divide into 2, 1, 8 and 7, 6, 2 elements each, correct? Now again these 2 elements list, again we are dividing into two sub problems, 4, 3, 4 and 3, then 2, 5, 2 and 5, and 1, 8, 1 and 8 here, and lastly 7, 6 means 7 and 6, correct? We are dividing into two until we are getting one element. Now we are starting the merging process and sorting process, correct? Merge and sort process. What we will do first, take these two numbers and merge together, and sort also. 4 and 3 we are comparing, 4 and 3, which is the lower one, 3. 3 write first, 3 then 4. Because the comparison, when we are writing 3 less than 4, 3 is the smaller one, 4 is the bigger number, because we need to sort into increasing order, correct? So 3, 4. Same like here we are merging and sorting, 2, 5. 2 and 5 comparison, 2 less than 5, so 2 will come first, 5 will be second. 1 and 8 comparison we are doing, 1 is the smaller number, so 1 will come first and 8 will be second. 7 and 6 again, 6 will come first, then 7. Now again these two lists merging together, okay, combine into one list. So how we are doing that process again, you can see. So first number here 3, compare with the first number here, 3 and 2. So what is the comparison? 2 less than 3, correct? So 2 will come first, okay, so 2 is done. Now after that 3 and next element here, 3 and 5 we are comparing. So 3 less than 5, so second number will come 3, okay, so 3 also done. Then 4 and 5 we are comparing, 4 less than 5, so 4 will come first, then 5 will come second, correct? So we will get a sorted list, that one. We will get a sorted list here. Same way we are comparing these two lists and merge and sort together, 1, 6, 7, 8. After that we are getting two sorted arrays here, two sorted list here, one list here and another list here. This one combine and sort here, we will merge into together and make a sorted list. So as I told you the comparison, first compare 2 and 1 here. So 1 we will get here in the sorted list, 1 will be here. Then 2 and 6 will comparison doing, so 2 will be here. Like that it is continuing, you will get the answer 1, 2, 3, 4, 5, 6, 7, 8. So this is the sorted list using the merge sort algorithm. That means 1, 2, 3, 4, 5, 6, 7, 8. Hope you understood this one, correct? Hope you understood how we are sorting a list of unordered numbers. Okay, let me go to the next example, example number 2. Use merge sort to sort the elements, B, D, A, F, G, H, Z, P, O, K into the alphabetic order. Show that all the steps using by the algorithm. So we have how many elements are there? You can check it here. Totally we have 10 elements. So 10 divided by 2. 10 divided by 2 means 5 we are getting. So first these 10 elements we are dividing into 5 elements, 2 list like this. First 5 elements, then next 5 elements, B, D, A, F, G, H, Z, P, O, K, dividing into 2 list. Now again this 5 divided into 2, okay, 5 means 5 divided by 2, correct? That means it will get 2.5. You can take the ceiling of that one, 2.5 ceiling means next number, that is 3. So in the first list we have 3 elements and second list the remaining element, that means 2 elements, correct? Now again these 3 we are dividing into 2, okay, 2 here and 1 here, okay. Then continue up to the 1 element, here also only 2 we are dividing into 2, 1 here and 1 here, okay. And here these 2 divide like B and D and this A is same. Hope you understood how we are dividing. Now we are going to combine the list, okay. Combine the list into one, like B and D, combine these two and sort also B and D. What is the comparison? We need to sort into alphabetic order, correct? First letter we can write B. B is coming first, then D will come, correct? So B and D. This A is also same, okay, and F, and next step what we are doing before F and G, B and D we are merging, B, D list merging with A. See here, B, D list merging with A. So which is the alphabetic order? Compare B and A first compare. So A will get it. Then D, B and D will come. See, without that one, B and D will come without comparison itself. It is because it is already in order. So B, D. So A, B, D. Okay. So that 3 number. Now this F and G we are merging together. F and G in alphabetic order. F will come first, then G will come. Correct. F, and J will come next. Now again we are combining these two and sorting. So we will do the comparison A and F first. See here this A and here F. So which one is alphabetically first? A letter, correct? So A will come first. So A done. After that we will compare B and F. So B will come first. So B next, B finished. So D and F will comparison we are doing. So D will come next. Then F will come. Then G will come, correct? So we will get a sorted list from that one, correct? That means this one, we can say this B, D, A, F, G, we are sorted and we are writing like this one, correct? A, B, D, F, G. Sorted list we are getting from that. Now same way the next portion also, here divide into two part. After that divide into two. Okay, so we will get one elements in each, correct? Here. Then we are starting combining and sorting, as I told you. Combine and sort here in one list. These two we are combining. After that we will combine, we will get a sorted list here. That means this list, this sub list we are sorted into a sorted list here like this. After that these two when we are comparing and combining, sorting, we will get A, B, D, F, G, H, K, O, P, Z, correct? So this is the sorted array by using merge sort algorithm. I hope you understood this one. Okay, now let me go to the next question. How many comparisons are required? How many comparisons? Here asking the question, how many comparisons are required to merge these pair of list using merge sort algorithm, correct? How many comparisons? See here we have one list 1, 3, 5, 7, 9. Second list we have 2, 4, 6, 8, 10. Two different lists. Okay, I will show here. The first list 1, 3, 5, 7 and 9. What is the second list? 2, 4, 6, 8 and 10. This was the list in the question. Separate two lists 2, 4, 6, 8, 10. So this list and this list already sorted list, correct? Already sorted list. That means we have two sorted list. Now we need to sort these two lists. So how many comparisons are needed? That is what our question. So we studied one rule. Maximum, how many comparisons are needed? Maximum comparisons, we studied one rule. M plus n minus 1, correct? Maximum. Sometime this much will not take. Before that it will be sorted. For example, here see, how many elements are there here in the sorted list? 1, 2, 3, 4, 5 elements, correct? 5 elements. And in the second sorted list, how many elements are there? 1, 2, 3, 4, 5. So we have 5 elements in the second sorted list. The first elements number we are calling M, and second sorted numbers, number of elements we have n. So what is m plus n minus 1? 5 plus 5 minus 1. 10 minus 1, that means 9 comparisons maximum. Okay, 9 comparisons maximum needed. So we will see how many comparison exactly is taken. Maximum 9 comparison, no more than this comparison. That is what the rule is telling here. I discussed that rule here. See, two sorted list, m elements and n elements can be merged into a sorted list using no more than, okay, no more than, that means maximum m plus n comparisons are needed. Now let me see how many comparisons exactly taking this question. So we will do that one. So first list, what is the first list here? 1, 3, 5, 7 and 9. What is the second list? You can 2, 4, 6, 8 and 10, correct? Now comparison we are starting now. What is the first comparison actually? First element here, compare with the first element here. So what is the comparison we are writing in the last? 1 less than 2, which is the smaller number 1. 1 less than 2, 2 is the bigger number, correct? So in the merged list, first number will come 1. So I am writing here the first number. Okay. So here we are starting only. Here this column I am not writing anything. First here starting 1. 1 is the first number. So this first number 1 is done now. This is finished now. Now what we are doing in the next comparison? write the before write the big, what are the balance number here? 3, 5, 7, 9. One already we are sorted. Here what are the balance? 2, 4, 6, 8 and 10. Correct. Now take the first elements in both sides. Here 3 and here 2. Correct. So take the comparison. What is the comparison there? 2 less than 3, because 2 is the smaller number, 3 is the next bigger number. Correct. So 2 less than 3. So which number we are taking in the sorted list? 2. So 1 already there, 2 will come in the sorted list. So 1 and 2. Now these 2 we done, finished that one. Now write the balance here in the next column. So here 3, 5, 7, 9. 2 already done. So 4, 6, 8 and 10. Correct. Now we are comparing again. This process recursively we are continuing. Here 3 and here 4. Correct. So what is the comparison? 3 less than 4. 3 is the smaller number. So we will select 3 into the list now. So what will be the list now? 1, 2 already there. Now 3 will come into that sorted list. So 1, 2, 3. So this 3 is done now. Okay. So 3 is done. Now what will be balance? You can write here 5, 7 and 9. And here 4, 6, 8 and 10. Now again we are starting the comparison. Here the first element is 5. Here the first element is 4. So what will be the comparison? 4 less than 5. Correct? 4 less than 5. So in the sorted list, one more number is coming. 1, 2, 3. After that we are taking the number 4. So what will be the balance numbers? You can write here. Numbers are 5, 7 and 9. Here 4 already done. So we can write 6 and 8, 10. Correct. 4 already done here. 6, 8 done. Now again we are going to compare this 5 first number here, the first number here, 5 and 6. So comparison 5 less than 6. 5 less than 6. So what number will come to the list now? 1, 2, 3 and 4 already we have. Now 5 is coming to the list, sorted list. So 5 is there. So this 5 is done. Now what are the remaining? Here 7 and 9 and here 6, 8 and 10. Correct. Now again we are starting the comparison here. 7 and 6. So we can write 6 less than 7. The comparison. So 6 will take to the sorted list again. So 1, 2, 3, 4, 5 and 6 now. So now 6 done. This number is gone. So write the remaining numbers. Here 7 and 9 and here 8 and 10, because 6 already finished. So again start the comparison here. 7 and 8 here. So what is the comparison? 7 less than 8. Correct. So which number will come to the sorted list? 1, 2, 3, 4, 5 and 6, 7. Correct. 7 will come to the list newly. So what are the balance numbers we can write? Here 9 will come and here the number 8 and 10 will come. Correct. Now one more comparison. Here 9 and here 8. So we can write 8 less than 9 will come here. So which number will come to the sorted list now? That means the number 8. So 1, 2, 3, 4, 5, 6, 7 and 8 now. Correct. So write the balance list. So here 9 will be there and here 8 already done. So 10 will be there. Now we comparison this 9 and 10 here. 9 and 10. So we can write the comparison as 9 less than 10. Correct. So in the sorted list, which number will come? 1, 2, 3, 4, 5, 6, 7, 8 and 9. Correct. So you can write the balance list now. So 9 done. So here nothing. Here 10 is balance. Now no need any comparison. This 10 automatically come to the sorted list, because that is the last number and it is the sorted number. So what will be the number answer getting? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So we are getting the sorted list here. That means that two sorted list we are combined and merged together, sorted, we will get a sorted list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be the answer, correct? This will be the answer. So you can see our question is how many comparisons are required? How many comparisons we are taken here? How many comparisons we are taken here? Actually 1, 2, 3, 4, 5, 6, 7, 8 and 9. That means totally 9 comparisons. This is the first one. Second, third, 4, 5, 6, 7, 8, 9. So I can write the answer. What will be the answer? Totally how many comparisons taken? 9 comparisons. So exactly 9 comparisons taken. Maximum how many comparisons will take? I told 9. So maximum comparison is taken here in this question. 9 out of 9, correct? All the comparison, 9 comparisons here we are taken for sorting this list by using merge sort algorithm. I hope you understood this question. Now one more question, we will do the same model. How many comparisons are required here? How many comparisons are required to merge these pair of list using merge sort algorithm? 1, 3, 4, 5, 6, 7, 8, 9, 10, correct? So first we will check maximum how many comparisons are needed. What was the first list? 1, 2, 3, 4 and 5. Okay. What was the second list? 6, 7, 8, 9 and 10. Okay. So these both are sorted list. Keep in your mind, these are sorted lists. In the first list, how many elements are there? 1, 2, 3, 4, 5 means 5 elements are there. And second list, how many elements are there? 1, 2, 3, 4, 5. 5 elements are there. Okay, that means m equal to 5, n equal to 5. So how many comparisons are needed? Maximum. Okay, this is maximum. Keep in your mind, maximum number of comparisons. Maximum number of comparisons equals m plus n minus 1. What is the m number? 5 plus n number 5 minus 1. So 10 minus 1 means 9 comparisons, correct? 9 comparisons maximum needed. Now we will see how many exactly here will take. Maybe sometime less than 9 comparison. Not need to take 9 comparisons sometime. So we will check this example. How many are taking this example? So I am writing the first list 1, 2, 3, 4 and 5. Second list we can write 6, 7, 8, 9 and 10. Correct? So as I told you, first we are comparing the first element here with the first element here. 1 and 6. So what will be the comparison? We can write here 1 less than 6 because 1 is the smallest number, 6 is the bigger number. Correct? So we will start here that comparison. Here we are not writing anything. Next line we are selected number 1 into the sorted list. So number 1 finished now. Write the balance from here. You can see what are the balance? 2, 3, 4 and 5. 1 already done. 1 already we are sent to the sorted list, merged list. Correct? Now here what are the numbers balance? You can write 6, 7, 8, 9 and 10. Now again we are taking the comparison. Here the first element 2, here first element 6. So what will be the comparison? 2 less than 6. So which element is selected to the sorted list, merged list? 1 and 2 selected, small number, correct? So what will be balance? We can write here 3, 4 and 5. Second list same 6, 7, 8, 9 and 10. All the numbers are remaining. Again we are starting the comparison. The first number here, 3 and 6. So what will be the comparison? 3 less than 6. So 3 is selected to the merged list. So 1, 2 and 3. Correct? So this 3 is done. So write the balance here 4 and 5. The second list it is same 6, 7, 8, 9, 10. Still not started the second list. Now again we are doing the comparison here 4 and here 6. So what will be the comparison? 4 less than 6, correct? So which number we are selecting to the sorted list or merged list? 1, 2, 3. After that 4 will select. Now right, we have balance here 5. Second list all the numbers are there, 6, 7, 8, 9 and 10. Now comparison again doing 5 and 6. So we can write 5 less than 6, correct? So which number will come to the sorted list? 1, 2, 3, 4. After that 5 will come. So what are the balance? Here nothing balance. Here done. Next list, what are the number balance? 6, 7, 8, 9, 10. Correct? Now no need any comparison. 6, 7, 8, 9, 10 is already sorted list. Correct? Because we are starting with the sorted list only. 6, 7, 8, 9, 10. So just merge with together this sorted with together with the sorted list. So we can write 1, 2, 3, 4, 5 already there. Now 6, 7, 8, 9, 10. You can write together 6, 7, 8, 9 and 10. So that we will get the sorted list here by using merge sort algorithm. See, this is the sorted list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many comparisons taken here you can see. This is the first comparison, second and third, fourth and fifth. How many comparison taken? 5 comparison only. Maximum comparisons, as I told you, 9 comparisons can take. But within 5 itself we are getting answer, correct? 5 comparisons. So originally 5 comparisons is the answer, but maximum comparison if it is asking, we can write a 9 comparison. Keep in your mind, 9 is maximum comparison, but here only took 5 comparison in the list. Okay, originally. Hope you understood that one. Okay. Now question number 3 we will go. Same model, one more question. How many comparisons are required? How many comparisons are required to merge this pair of list using merge sort algorithm? Correct. So in this question you have 2 sorted lists are there, 1, 5, 6, 7, 8, 2, 3, 4, 9, 10. Correct. So we have 2 lists, 1, 5, 6, 7, 8, 2, 3, 4, 9, 10. 2 sorted list. First list you know we have 5 elements. Second list we have 5 elements. That means m equal to 5 elements, n equal to 5 elements. So maximum number of comparisons means m plus n minus 1, as I told. So 5 plus 5 minus 1, 9 comparisons maximum needed, correct? So these 2 lists if you want to merge and sort one combined list, maximum m plus n minus 1, 9 comparisons are needed. Now exactly how many comparisons are taking, we can check it here. Let me see the first list we can write here. 1, 5, 6, 7 and 8. Second list 2, 3, 4, 9 and 10. Correct. Now we are starting the comparison. The first number here 1, first number here 2. So 1 less than 2 is the comparison. 1 we are selecting to the merged list. I can write 1 here. Okay. Now we can write the balance here 5, 6, 7, 8 and here 2, 3, 4, 9 and 10. Correct. Only one number we finished, one number we done. Now again we are going to the comparison here 5 and here 2, first numbers. So we can write 2 less than 5, correct. So 1 together 2 will come to the list, merged list, 1, 2 here now. So number 2 now done here, this number, write the remaining numbers here 5, 6, 7 and 8, here 3, 4, 9 and 10, correct. Now again we are comparing the first 2 numbers, first here 5 and first here 3. So 3 less than 5 is the comparison. So number 3 will come to the merged list, 1, 2 and 3, correct. Now again we can write the remaining here 5, 6, 7, 8. Now from here 3 we done already. So the remaining 4, 9 and 10. Hope you understood. Now continue this process. Here 5 and here 4. 4 less than 5 is the comparison. So the list, merged list, it will come 4 also, 1, 2, 3, 4. Now you can write the remaining What are the remaining? Which number is gone? 4 is gone now. So the remaining numbers here 5, 6, 7 and 8. Here 9 and 10 will be there. Now again the number 5 and 9 we are comparing. So 5 less than 9. So 5 will come to the list. 1, 2, 3, 4. After that 5 will come to the list. So now 5 is done. Write the remaining 6, 7 and 8. Here 9 and 10 same, correct? Now again the first number here 6, here 9. So 6 less than 9, the comparison. So 1, 2, 3, 4, 5, 6 also will come to the list now, merged list. So we can say this 6 number also done. Now the remaining here 7 and 8, here 9 and 10, correct? Now again comparison with 7 and 9. So we can say 7 less than 9 we will get, correct? 7 less than 9 here. So 7 will come to the list. So 1, 2, 3, 4, 5, 6 and 7. So we have this 7 also done. So balance is here 8, here 9 and here 10, correct? Now next comparison, this 8 and 9. So 8 less than 9. 8 will come to the list. So 1, 2, 3, 4, 5, 6, 7 and 8. So what are the remaining? This 8 done. Now the balance here nothing. Here 9 and 10. So one side done means 9 and 10 already sorted one, correct? So we can write the answer now. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 you can write together. Okay, and there is no need any comparison. It is already sorted list. So we got the answer here, the merged list, correct? Merged and sorted list. So how many comparisons are taken? You can count here. This is 1, 2, 3, 4, 5, 6, 7 and 8. So how many comparisons are taken? 8 comparisons are taken. But maximum comparison how many in these two lists? 9 comparison, correct? Maximum 9 comparison. But this question when we are doing originally how many comparisons only needed? 8 comparisons only needed. So that we will get the list. Hope you understood this one. Okay, now we have a question here. Question number 3. Write the maximum number of comparison. Maximum number. Only we need to calculate maximum number. No need to find the original number. Maximum number of comparisons are required to merge these pair of lists using merge sort algorithm. So you can see this is the first list, sorted list. This is the second sorted list. How many elements are in the first list? 1, 2, 3, 4, 5 elements, correct? 5 numbers are there. And second list, how many elements are there? There also 5 elements are there, correct? 1, 2, 3, 4, 5. So m equal to 5 and n equal to 5. So we can write maximum number of comparisons. Maximum number of comparisons equal to m plus n minus 1. M means 5 plus n also 5 minus 1. 10 minus 1 means 9 comparisons are needed. So I hope you understood how to do the merge sort for sorting the numbers. Okay, and how to find the comparison, number of comparisons from these questions. So this is the topic here, this recorded class. I hope all of you understood. So please subscribe my channel for getting more recorded classes. Thank you very much.